I wanted to briefly go over some examples from section 2.1. In section 2.1, we were talking about our integer exponents and how to simplify in our exponential expressions, and then also just using them to evaluate. And so if you look in the notes in Canvas, this table is there. That might be a nice thing to have when you're looking for your test notes. These are just our rules that we followed when we were trying to simplify our exponential expressions. So just a few examples. One thing we talked about was just being really careful with our negative values. So, and remember, in order for that negative to be part of the base, it does have to be combined with a parenthesis. So something like this, -3 to the fourth power, that negative and that 3 are together inside the parentheses. That means the base of this is the -3. If we expanded this, you do not have to, but if we did, it would be -3 times -3 times -3. That even number of negatives will cancel each other out and will give us a positive outcome. Our value will be 81. Whereas if we asked the question -3 to the fourth power like this, with no parentheses, this means that our exponential is only using the 3 as the base. So we would be taking that 3 to the fourth power and then tacking on a negative after we had evaluated that 3 to the fourth power. So still getting 81, but because of this negative here, our end result would be -81. We talked about just like, again, using these things to do simple evaluations with numerical bases, something like 18 to the 0 power. We said anything to the 0 power is going to equal 1. If we had a negative exponent, so 7 to the -2, for example, we said we cannot evaluate these until they are positive exponents. In order to change them to positive exponents, we have to change their position. So this is going to move down into a denominator position, making this a fraction, 1 over 7 squared. Now that it's moved, we now have a positive exponent. We can evaluate that 7 to the second power. That would be 49. This is going to stay a fraction, 1 over 49. Um, and then we also talked about making sure that we acknowledge which value that exponent is applied to. So if we had something like 5x to the -3 power, that x to the -3 is the only exponential. That 5 has an exponent of 1, even though we don't traditionally write that exponent of 1. So if we were going to simplify this expression, we could only move this part of it to that denominator position because it is the only thing that has a negative exponent. So we could rewrite this as 5 over x to the third if we were trying to simplify, which is what our goal was with most of these problems. If we had something like, um, let's say, 12 to the, mm, let's say -4 over 12 to the -6, and we were trying to simplify that, we had a couple of options of what we could do. One thing we could do is we could switch the positions of these things to make it so that we no longer had negative exponents. That would be fine. Another option we have is to subtract the upper exponent from the lower exponent because we had that rule about division. Either way that we do this, we should all get the same answer though. Let's just say we dealt with the negative exponents. We could rewrite this as 12 to the sixth power because it moves up to make it positive, over 12 to the fourth power because that one moves down to make it have a positive exponent. Now this is still a fraction, there is still division. With that, we are still doing a subtraction between the exponents. So 6 minus 4, which would finally get us to 12 to the second power. And when we take 12 to the second power, we would get that 144. If we had something like, excuse me, 2x squared y to the fifth to the third power, for example, we had a rule that told us that we had to basically distribute that exponent to all of the bases inside of this parentheses. Again, do not forget that this value, even though it does not look like it has an exponent, always has an implied exponent of 1. So for the 2, we would have 1 times 3. For the x, we would have 2 times 3. And for the y, we would have 5 times 3. So that makes this 2 to the third, x to the sixth, y to the 15th. If we have a numerical base, I did ask us to evaluate that. 2 to the third power, 2 times 2 is 4. 4 times 2 should give us 8. And so we would end up with this exponential expression, and that would be all that we could do to that particular exponential expression. If we had something like 9x to the third times negative 2x to the seventh, for example, here there are parentheses, but there's no exponent out here that we have to distribute. So that parentheses really is not necessary. This is really just asking us to take 9x to the third and multiply it with negative 2x to the seventh. When we do that, we can combine the coefficients together, so that 9 and that negative 2, to give us a negative 18. When we multiply the x to the third and the x to the seventh, we are adding those powers, just like our property or our rule told us we could. So this would turn into negative 18x to the 10th power, and that would be all we could do with that particular expression. Let's do one more, and then I'll end this. So let's say we had something like, excuse me, 15 and then x squared y to the let's say fifth over let's say 20x to the third y to the negative 2. So if we're going to simplify this, we have a lot of different things we can do here. I recommended that we start with the parentheses. Again, that y does not have an exponent. It does have an implied exponent of 1. So when I distribute that 5 to both of those exponents, the 15 is not changing. It is not inside the parentheses. That x will become to the 10th power because 2 times 5 gives us 10. That y will become to the 5th power because 1 times 5 gives us 5. We have that over 20, x to the third, y to the negative 2. Here again, there are different possibilities of what we can do. As long as we're not breaking any of our rules that we started with, we should still all end up in the same place with our answer. So for example, I might want to get rid of that negative exponent by moving that y to the negative 2 to the top of the problem. So I would have 15x to the 10th power, y to the 5th power, y to the 2nd power, over 20x to the third. At this point, because I'm multiplying these two things together and they have the same base, we can add their exponents. So 5 plus 2 would give us a total of 7. I could also take care of this repeated base of x by subtracting those exponents. So I would have 10 minus 3 for the x. For the y, I said we would have 5 plus 2. When we do that subtraction, it's like we're moving this x up here is kind of what it is. But we can't move this 20 because it doesn't have an exponent. So that 20 is going to have to stay in the denominator. So then we're going to have 15x to the 7th, y to the 7th over 20. I will still need to reduce that fraction. 15 and 20 both divide by 5. And so when I do that, I finally get to my end result of 3 x to the 7th, y to the 7th, all over 4. We could also write this as a fraction in the front, 3/4 with that x to the 7th, y to the 7th off the side. They're both the same. So I hope that helps as far as a little few examples, more from section 2.1, where we were talking about using our rules of exponents.